I'm here with my colleague Ollie, so we are doing a handover around about the middle of this presentation. But I'm going to talk a little bit about biosolids recovery. Most of you in the room probably have no idea what biosolids are and the recovery of those. But in terms of a picture, it gives you an idea here. Biosolids are the byproduct of wastewater treatment. One of the byproducts when wastewater is treated at a treatment plant, you get clean water and you get a sludge product which is treated in this case by further anaerobic digestion and then dewatered to produce a sludge biosolid cake. It's not the most talked about end of the business, it's not the prettiest end of the business, but it does produce a very good and popular organic fertilizer for farmers. It's not popular with large retail brands because of the emotive aspects of the product, but in countries like the UK with 60 million people, you produce quite a lot of byproduct from the wastewater treatment, and it needs to be managed. The EPA in Ireland, and in fact also in most of Western Europe, recognise that recovery of this product to land as a fertilizer and as a soil improver is the best and most economic and most environmentally friendly way of recovering the product. In a farm with continual tillage, where you're taking off straw and taking off grain every year, you're depleting the soil of organic matter. And so if you just keep putting chemical fertilizers on it without any organic matter, you don't maintain the goodness of the soil. So it's a very popular product, particularly with large arable farmers in England, where Severn-Trent is. Severn-Trent, the client that we have is, it's a combination of the two rivers, the Severn and the Trent. It's got a catchment of about 10 million people. It's about 4.2 million households. So to put that in perspective, it's about 3 times the size of the Republic of Ireland, and it's one water authority. In Ireland, we've got Irish Water coming in, so Irish Water would be a similar but slightly smaller water authority than Severn-Trent. I think it's the second largest in England and Wales. So they produce 700,000 tonnes of this product annually from 38 large production centres. And that's all recovered to land as a fertilizer and a soil improver. And just to put it in perspective, there's 34,000 hectares of arable land that's required in terms of the fertilizer value of this product, and that's across 4,000 farms, and there's a significant number of individual fields. Now, in 2010, Severn-Trent Water faced some issues. The practice of recovering this product to land is highly regulated. You have to continually assess the product that's being produced, the fertilizer product, for pathogens and for heavy metals. It has to be continually monitored, and every field must be tested for suitability to receive the fertilizer product, and every tonne that then is recovered to those fields must be planned in terms of a nutrient management plan for the field and tracked and recorded. So every single load, every single tonne must be tracked and recorded, and there's continually evolving reporting requirements governed by the EA, which is the UK equivalent of the EPA. It's the Environment Agency in the UK. And farmers are starting across England now to pay for this product to be supplied and spread to their fields because they see the value in it. And there's a requirement for the company to record that and manage it somehow in terms of invoicing farmers and capturing that revenue stream. They had an old mainframe record-keeping system, which was, in 2010, it was one of those classic old black screen, green font mainframe systems, and it simply wasn't keeping pace. So the mainframe system was being run, but it was surrounded by a whole host of smaller Excel type recording systems and systems within the biosolids team in Severn-Trent, and it was an issue, and it was also going to be decommissioned. So that's when they tendered for work, and ClearPower and Compass provided a solution which was actually a little bit different to what the other vendors were bidding in on. And we proposed to use the existing Microsoft and SQL Server technology that they had, rather than a separate standalone GIS recording system that a lot of the other water companies in the UK would have. And the combination of ClearPower's experience in the biosolids recovery, the actual front-end work, and Compass's excellence in the .NET world and the GIS world allowed us to propose a solution that was significantly different than the competition, and a distributed system across their 38 centres, and also to allow access over the web for the contractors involved in the land spreading activity. You see here the picture shows basically the communication requirement between the internal team and the Environment Agency, and then out in the field in terms of contractors. Benefits of this: we've done phase 1. Ollie's going to talk a bit more detail about that. We've replaced the mainframe system, and we've delivered quite significant administration cost savings. And we're starting now to look at operational efficiencies in terms of saving costs in the field, and we've allowed them to capture the invoicing to the farmers and link that back in with a SAP system for the accounts. And the major, I suppose, benefit is that they now feel more comfortably compliant with the EA requirements, and they can do ad hoc reports whenever they want. They can pull various different reports on the activity. So I suppose it's a story of how we move from mainframe into a distributed .NET, effectively web-based application, to deliver something very specific. And you can see, and Ollie's going to talk about it in a bit more detail now, how GIS comes into play. And now, hand over to Ollie. Thanks very much.
Hello, thanks a lot, Simon. The first phase, I think for Severn Trent Water, it could probably be, I suppose it might be a bit of a horror movie really, probably Escape from the Mainframe or something they would call it, but over the last year we managed to release them from their mainframe woes, and they're now running on a new web-based .NET system that we developed for them. So I suppose for us as a company, much more of a GIS side we work on, we're now moving into the more interesting phase where we can start to empower the users. I mean, at the moment, the land bank that they're managing, you can see, it's not shown on the screen, but they have about 20,000 square kilometres of fields. They have about 10,000 active fields that they've put biosolids to land over the last 3 to 4 years, and they probably manage about 3,000 fields a year to spread biosolids, and that's all managed by 3 people. So as you can imagine, they're fairly busy people at the moment, and they currently do that task using absolutely no GIS, no spatial information. So everything they do is based at looking at paper maps or Google Maps at maximum, and they have no ability to mine their data. So one of the major factors we're proposing and we're developing for them in their next phase of the development is the use of GIS. And like we've seen here, this is the nitrate vulnerable zones for the UK, as you can see that a lot of the middle of the screen here is their land. So they have a major nitrate vulnerable zone that they have to manage. So one of the major things with GIS is the ability for them to easily identify problem areas. For each field that they look at, they have to look at over 35 factors, some spatial, some not spatial. You can't sludge to land if the land is too wet, if it's near boreholes, if it's in nitrate vulnerable zones, if the metal additions are too high. There's a whole bunch of factors they have to work on. So at the moment, for every single field, someone has to go and individually visit that field, fill in a paper form, and then go back and enter that into a system, which is a very laborious process, and we're hoping to speed up as part of the phase 2 of the project. So some of those factors are nitrate vulnerable zones. These are areas which are identified by the EA in the UK, and you can only spread certain amounts of nitrogen to land. Also aquifer zones, so areas where there's water that's extracted for human consumption. Then things like sites of special interest. People don't really appreciate you going putting biosolids on monuments and things. It has been done in the past, but people get in a lot of trouble for doing it. And then again, there's lots more things, so natural occurring chemicals, spring boreholes, overhead power lines. You'd be amazed at where you can and cannot spread. So one of the major things we've just started working with them is, as part of the business case for this, we started looking at the metal additions. For any land that you spread biosolids on, it contains a certain amount of metals, and there's certain limits for the amount of biosolids that can be spread. And they do soil samples at certain times during the stages of recycling to land. So we started looking at the GIS for this, and at the moment we're just using our desktop, but we're going to provide them with a browser-based solution so it can be accessed by the whole of Severn Trent Water. So we can see here that anything that's green and highlighted is good. I tried to find some signs of failure within the current data we have, but unfortunately there isn't many fields that fail on metals, so they're very good at managing their land at the moment. So if we go through, we can see all the different types of metals, and this is percentage to the maximum limit that can be delivered. So these fields are actually quite good for all of the heavy metals that they have to check. On the field pH side, you can see we're slowly going from to orange, so there's no reds, unfortunately, but so it means that all these fields here would be good to spread on. So one of the major problems they've had as well is that they do sampling. It's not the farmer that pays for sampling of land to work out metal additions, it's Severn Trent Water that have to pay for it. And in the middle of the UK, there's actually whole belts of land that fail samples just by naturally occurring metals. And they've had problems in the past of they've gone and sampled these areas and then maybe come back 5 years later and resampled them and discovered both times they failed. And these, we're not talking kind of tens of thousands, we're talking hundreds of thousands. They've spent sampling massive amounts of land to check for heavy metals, and they've gone back and done that again, where if they had a map to see this data, they could have avoided spending that money. So there is a big cost-saving benefit to empowering the users just simply by providing them with a map to look at. So I mean, that's the basic level that I've talked about. I mean, once we start moving forwards with this, the GIS analysis that can be done and the data mining that can be done on the non-spatial data, but now we have field boundaries and everything that can be linked up is quite interesting. One of the major other things we do is we work with the regulatory side. So at the moment, Severn Trent Water, every bit of biosolids to land is either weighed or logged through a logging system on the treatment sites. So the next thing we're going to be doing is linking up the loggers that are on the sites to the biosolids management system. So for every single tonne of biosolids that goes to land, we can manage that and ensure that there's no biosolids delivered to the wrong field, because it's quite a problem in the past where contractors have gone and taken 20 tonnes of sludge. Basically, when you see a big truck driving down the road and you get a funny smell, it's probably because it's got biosolids in it. Those trucks have been known to go to land and build stockpiles of maybe 1,000 tonnes of biosolids to then realise they've put it in the wrong place and they've delivered it to the wrong farmer. So it's quite a costly process to go and take that biosolids and bring it back to a treatment works and deliver it other places. So the biosystem is going to be used to much more regulate that system and ensure that biosolids isn't taken to the wrong places. So the communication between the biosystem and the delivery systems on the treatment works is going to be implemented. So every single tonne of biosolids that goes to land is fully documented and can be reported to the EA through the reporting procedures that have to be provided every year. So only authorised deliveries will be taken to land. And hopefully this will provide a reduction in the costly misdelivery of biosolids.